My name is Genghis Khan. You see me in such fine quality chemistry educational videos as KSP, is that a kilo teaspoon? And what's up with dropping the base in my solubility product? Okay, we're continuing on the series of KSP problems dealing with the equilibrium of the solubility product. And in the previous video, I made one where you were given the solubility, the molar solubility. Okay, sorry, it's after school, I'm a little tired. Now, in this case here, it says determine the KSP of calcium arsenate, and they gave that to us, given that its solubility is 0.03 grams per liter. Now, in one sense, what you need to do for any time you work with an equilibrium problem, which this is a KSP, so it's equilibrium, you have to change it into molarity. And molarity is moles over liters. It doesn't matter if it's 1 mole or a bazillion moles, or 1 liter or half a liter or a gazillion liters, it's still moles over liters when we look at concentration. So we went ahead and we wrote out our equation here, how it dissociates. Here's our calcium arsenate. It's a solid. I'll get to I crossed it out in a moment. Now it's going back and forth, and you've got 3 calciums in aqueous form and 2 arsenates in aqueous form. So that's what we've got. Now here we have KSP. Now our formula, because there's 3 of these calciums, it'll be 3 times whatever the concentration is here, cubed, times 2, whatever the concentration is here of this, cubed. Squared, sorry, not cubed, squared. There's my typo. Okay, got it. Genghis Khan can make mistakes. All right. So now we're looking and say, well, why in the world did you cross this out? Well, remember, a solid doesn't contribute to the dissolving process. Not really. It's not contributing to that equilibrium. Okay? And the idea behind equilibrium, remember how the reaction's going to go back and forth. I whip my hair back and forth like that kind of thing. So now we figured out, okay, we need concentrations. How do we go about this? Well, notice that it's 0.03 grams per liter. Okay, so we got the liter part down. If it was, say, 100 milliliters, then we would need to multiply it. We would need to change it to liters. And we can multiply by 10 to get the liters, or we can convert it and make it a fraction of a liter. You'll still get the same answer. It doesn't matter. Okay, so it's liters. That'll make things easier. So now we have to figure out, well, how many moles of calcium arsenate do we have, given that we have 0.03 grams, which isn't a lot if you stop and think about it. Well, I figured out the grams per mole for calcium arsenate is 398.08 grams per mole. Okay, and for us to find the moles, it's going to equal the grams you have over the grams per mole. That would be kind of an important thing. So that's going to get us 0.03 grams over 398.08 grams per mole. So this is what you've got. Now we divide it out, and it shouldn't be a really big surprise. It's going to be a super small number. In fact, it's going to be 7.54 times 10 to the minus 5th molar concentration. Woo! That's really, really not concentrated. Barely anything in there. But I would recommend drinking calcium arsenate. It's just one of those things that you don't want to go and drink something that you don't know what's in it. Okay. So now we have our situation where we figured out the molarity, the molar concentration, and we have to go ahead and go back. Remember that for the calcium, we're going to have 3 times what this concentration is, because remember, we've got 3 calciums in our thing, right? And we are going to need to cube that. And we also multiply by the other one, where we are looking at the arsenate, which again is also 2 times 7.54 times 10 to the minus 5th, and we square that bad boy. Now you'd say, well, wait a minute, what's up with the 2 and the 3? Well, remember, when it breaks down, you got 3 calciums and you got 2 arsenates. That's why you gotta see this here. So remember, it's triple the concentration that we originally have here. Okay, this is the concentration for the entire Ca3ASO42, you see. That's the entire concentration. So when we're looking at breaking it down to the CAs, how many of these CAs do we have? You have to go 3 times this and 2 times the arsenate. Now, you have to take it to the power, okay, based off of what you got here and here, okay? That is part of the equilibrium formula, all right, that we had mentioned earlier. So, let's go ahead, let's continue. So, on calculating this, guys, this is what we have. We have 1.16 times 10 to the minus 11th multiplied by 2.27 times 10 to the minus 8th. Wow. Wow. Now notice I'm not paying attention to my units here because when you're dealing with, you know, molar cubed, molar squared, doesn't make a whole lot of sense. Okay, KSP is KSP and you let it be. Hey, that rhymes. So we're going to multiply this bad boy down and our final answer, yes, after all this work, is 2.64 times 10 to the minus 19th. That, ladies and gentlemen, is our KSP or calcium arsenate. I think it's ASO4, I think. What was it? 4? Was it ASO4? Yes. Well, I just wanted to make sure I got it right. 2. This is it. Of course, it doesn't follow. So this is it, ladies and gentlemen. This is our entire thing for calcium arsenate. Hey, I hope this worked out. Now, in this case here, one last thing. Remember, if you're dealing with grams per every 100 milliliters, then change the 100 milliliters to liters. Or maybe they give it to you in like 10 milliliters. Change the 10 milliliters to the 1,000 milliliters so you get your 1 liter. Okay, guys, that's it. I'm Genghis Khan. Hey, have a good time conquering things out there. Catch you later.